to start today's session. Welcome all of you for the third live session for Smart Grid Basic to Advanced Technologies NPTEL course. I am Gagan Meena and I am currently doing PhD in Power System Engineering at IIT Bombay. Let us start. So we'll have the same agenda as we have followed for last two sessions also. We'll start with an overview of week 3, then we will discuss some questions and then finally doubts. So these are deadlines for assignment 3 and 4. For assignment 3 it's tomorrow and for assignment 4 it's 23rd August. So please submit the assignment on time, and the live recordings for these sessions is available on this YouTube channel. And the link is also available on the problem solving session tab. Before moving on to the overview of week 3, last time someone asked this question regarding this effect of solar irradiance and temperature on PV characteristics. So how these two are affecting, how the characteristics changes because of change in irradiance or the temperature. So this first, let us see how the PV characteristics changes because of change in the solar irradiance. So we have seen that this is the mathematical model or equivalent circuit for solar PV cell. This is photogenerated current, and some part of it is going in through this diode and the rest is going through this shunt, and finally we are getting IPV. So IPV is this IL minus ID minus ISH, which is this, and this voltage across this is VPV plus IPV into RS. The same is written here. So we have PV characteristics is like this. This is the short circuit current and this is the open circuit voltage. So we have to see what happens to both of them when there is an increase in irradiance or decrease in irradiance. So for first, let us consider the short circuit current. So at short circuit, what will happen? So this is shorted. So this voltage becomes 0 and IPV is equals to I short circuit current. So if we substitute these two values in this equation, the ISC is IL minus I0, VPV is 0, this is also 0, this becomes ISC. And since this RSH shunt resistance is very large in comparison to the series, so this terms we can neglect this term. And RSS is also very small. So this also we can neglect, because this is 0, e raised to power 0 is 1, 1 minus 1 is 0. So it is simply a linear relationship. So if there is an increase in irradiance, the short circuit current will also increase. If it is decreasing, then it will also decrease. So this is with respect to the short circuit current. And what happens for the open circuit voltage? And this is the case for open circuit voltage. We have for open circuit, the current will become 0. This IPV. So here. So this is 0. This is open circuit voltage and IPV will become 0. So these two values we have to substitute in this equation. So IPV is 0 and this becomes VPV is VOC. This is also VOC. And here also we can again assume RSH is very large, and open circuit voltage we have seen for a cell is around 20-30 volts. This is in kilo ohm, so we can neglect this. This is 0. So now we are here. If we take IL this side, then it becomes IL by I0 plus 1. And VOC can be written like this. And again this 1 can be neglected. So we can see VOC has a logarithmic relationship with the photogenerated current. So increase in VOC with irradiance will be negligible. It will be very small because it is following logarithmic relationship. That is why if this is the characteristics, if irradiance increases, then IL will increase more, but VOC will increase very less. Similarly, for temperature, due to increase in temperature, there is an increase in short circuit current while the VOC reduces. Right. If we use these two equations, we can, it is a big derivation, we have to differentiate this dVOC, differentiate this with respect to time and substitute this equation, then you will finally get that this is negatively related with temperature. So if temperature is increasing, then the voltage, the open circuit voltage is reducing. That is, this temperature coefficient is negative. And since power is product of V and I, this is reducing, overall power will reduce. dP by dt will be negative because one change is positive, one change is negative. So overall it's a product, so power will also reduce. So is this clear? Is there any doubt in this?
If temperature increases, voltage of the PV cell decreases.
Yes, because of this negative sign.
That is why the floating solar cells are there for the compensation of temperature.
Correct. So that is one advantage of having floating solar panels, because they will help in cooling. The temperature will not be that much because water is there below, so it will always help in cool. It will create a cooling effect, and especially on higher altitude, the cooling effect will be much more significant. That is where in Switzerland they have put one floating solar plant on Alps. Oh, there is one lake.
So, but that suppose on what you say, like in India, where temperature is less, but there the output is more for the PV cell. Can we say like this? Because irradiation is also more there.
Yes.
So it is better to install solar cell at Leh rather than what you say desert area, Rajasthan.
Yeah, Leh is also a desert. It is called a cold desert.
That is why if we have to compare both desert, cold as well as hot, I think then Leh is the better option for solar cell.
Yeah, that is why we are planning one very big, around 13 gigawatt solar plant, solar and battery storage in Leh region. So that is planned. The government is already, that has been sanctioned. So it will be established, constructed very soon.
In PLI scheme of solar, there is a factor 0.3, 0.4 negative, minus. What is that?
Factor for
Or temperature, regarding temperature with respect to PV max.
Actually, I'm not aware of that. So what is that factor? I'll have to check.
So can we say that on the hills that irradiation is more than the plains?
No, it depends upon the latitude also. Latitude, longitude, all these things determine the solar irradiance. So if we go higher, then latitude increases and the sun rays are not direct, they are diffused. That is why in European countries, it is this solar irradiance is not that much. So between 30-degree latitude north and south, solar irradiance is, we can say, maximum. That is, India falls in that belt. So that is why we have started this International Solar Alliance. India is a founding member of that alliance. But with altitude, the temperature certainly reduces. As we go higher and higher, temperature reduces. And if latitude in India, irradiance is already good. So higher altitude will have a benefit of this, provided there is no shadow. We need open area. So on hills, the shadow is also a problem. So all these factors we have to consider we have to take into account. Shadowing creates a lot of problem. It reduces the output of the solar overall system, and also it creates hotspot because there is imbalance. Somewhere temperature is more, somewhere it's less. So it creates localized heating hotspot, and that reduces the life of the solar panels. So everything before at any location where we want to construct a new solar farm, a detailed analysis has to be carried out before doing that. That include a shadowing analysis also. For historical irradiance data is also is considered, and then shadowing analysis also done, and overall output is calculated after incorporating the shadowing analysis. Then it is decided whether this location is good or not. Shall we move ahead? Okay, so let's go through overview of week 3. So week 3 is, can you tell what was the topic for week 3? Means what was the main content for week 3? Theme, we can say theme of week 3.
Storage. Storage is the main thing.
Correct. So it was about energy storage devices. Why do we need them? What is the use, classification, all these things. So these things we discussed in 5 lectures. First was an introduction to energy storage, then different types of energy storage, analytical modeling, sizing, siting, and battery management system. So introduction was first, purpose of storage was discussed. So what is the purpose of energy storage?
Stabilization of voltage and frequency, the main
purpose. That we already have some mechanism to do that. Why are we going for storage?
To flatten the load curve, because we have to cater for peak load, and storage will help in to cater the peak loads.
Yeah, that is one of the use cases.
How to utilize the energy further?
Sorry, utilize the energy for
Further.
yeah, we can store energy and then we can use it when generation is less. So
energy security is also one of the main reasons.
So yes, energy resource adequacy, we call it resource adequacy. Especially this energy storage, yes, ancillary service is also one of their benefits. So actually storage was there, it has been there since more than 200 years. It was there since 1800s, but
to
we are
increase the penetration of renewable
correct.
sources.
Yeah, storage is it was there, but because of this increasing penetration of renewables, we are shifting more and more towards these non-conventional resources, and they are intermittent, highly dependent on the climate and weather phenomena. So it's quite uncertain. Solar and PV output is not certain, and we want firm output from them. Conventional resources, they can provide firm output. If we avoid those contingency and any kind of unforeseen outages, but apart from those, they can always provide whatever they have been scheduled to provide. But these renewable energy resources, that is not the case with them. Sudden cloud cover will reduce the output of solar. So energy storage can help in capacity farming and fixing their output, maintaining their scheduled output. Even though the output, the radiance may be less, temperature may be more, but still, if storage is there, energy stored in storage, then it can help in maintaining the same output from the solar PV plant or wind. And another thing is the excess renewable generation can also be stored so that it can be utilized when solar is not there or wind is low.
So can, as a utility consumer, can we ask grid to say, suppose I want 70% of power from renewable and 30% from that conventional? Can we, as a customer, can we say like this to the grid?
We don't have any control on the power flow. We don't know how much power is, whatever we are drawing. We don't know how much of that is coming from solar or conventional or non-conventional. The network has no control over that. It will be, whenever power is injected, the network impedances, where the load is, all those things will determine where the power flows. But thing is that now government, what we can do is that
why I am asking this, because say suppose solar energy is okay, cheap, price is less, and coal energy is costly. Say suppose 6 rupees and solar energy is 4 rupees. So as a customer, I can say I want from 4 rupees, not from 6 rupees.
Yes, we can do that. So we can, instead of asking the network operator, we can directly, we have permission, network operator has already given permission, you can go for bilateral contracts. So we can directly go to those renewable generators and ask them to do a bilateral contract that for next 10 years I am ready to buy from you at this price. If he is willing, then both of them can agree on a contract and they can continue to the load can consume power from that generator for next 10 years. So that time...
But presently, what is happening, sir, I need someone who is doing that. See, presently what is happening, there is bids, okay? Bids, the generator offer a bid and then consumer, settle that bid. Yes. Now, in that bidding, there is no customer cannot know that whether it is coming from renewable or whether it is coming from conventional. So it all depends upon the bidding price. So what I want to say, can we have a system wherein I will say only no, I need only from the solar because I want to pay 4 rupees, and with that imposition, the grid operator will forcefully switch on their PV panel. Otherwise, they may say, okay, no, we are not switching our panel. so we will give you from 7 rupees or 8 rupees. Is that right?
Actually, this network network operator has, it can monitor the this network flows, but no one has a control over how much power will flow through the network. We only have injection at a particular node. The generator is injecting, and at a particular node the load is drawing the power, and network will decide how the power will flow through a particular corridor. So, and what you are saying is that I want to purchase from solar, then we have that option, because in India this bidding, what we are saying, market operation is only 5 to 6% of the total transaction that happens. Rest, more than 90%, around 90%, it's already it's contracts. These are around 70% is almost these contracts, long-term power purchase agreements. Rest are from different markets. So we can always do that. If I want to purchase from solar, I can make contract. So that network operator will have to follow those contracts. They will have those detail of contracts, and they know that it is going to be there. So he will get, so that load is certain that he can consume, he will get power at a particular price, lower price. So whatever may be the flow in the network, but he will get the generation at that price only. So that is a certainty because for the contract. But in market there is no certainty. If we go to real time market, day ahead market, we don't know what will be the price. So there is always a risk associated with market. Prices may be high or low. So to hedge against those risk of high prices, most of the load entities, they go for these contracts.
So also MOP has come with a time of day tariff, in which they have defined solar hours for 8 hours, in which at least 20% less will be tariff than the normal.
Okay. That is also good. So similarly, to encourage this energy storage, they have come up with this high price day ahead market. So only those generators which have their bids more than 12 rupees per kilowatt hour, they will be able to participate in that. So no nuclear, these nuclear, these coal based, they will not be able to participate. So gas based, battery energy storage, they can participate in those markets. So to incentivize these energy storage, because storage is right now very costly, they have started this, because in this summer only they have started this, because this time this demand forecast was around 236 gigawatts something. From next year it will be there. We have certain energy storages in India, and it will further, several new projects have been sanctioned, and within 2-3 years we will see lot of energy storage in India. NTPC, several PSUs are also, they have installed energy storages in their complexes, power plants. First one was installed by this Tata in Delhi.
What is the maximum? What is the practical maximum limit? What type of storage there NTPC or what you said is installing?
It's lithium-ion battery. They are using lithium-ion batteries, because other is then practically those which are available for grid scale storages are, one is sodium sulfur batteries, but their efficiency is low. They are generally used for long duration discharge, for 6 hour, 8 hour. And lithium ion are being used up to 4 hour, 2 hour, 4 hour discharge duration. So right now we are using only 2 hour batteries, 4 hour batteries. So those are all lithium based. All over world, everywhere in the globe, throughout the globe, these grid scale batteries are lithium ion based, and they have discharge duration of either 2 hour or 4 hour. maximum storage you will find in Australia.
So that means now the substation also, just like a capacitor bank, they have now what you say sodium sulfur batteries bank.
Sodium sulfur in India we don't have it. Mostly in Japan. It's a Japanese company, NGK Insulators. They produce these sodium sulfur batteries. So they are producing, and most of these sodium sulfur batteries are there in Japan. One is there in Abu Dhabi, around 108 megawatt, 8-hour discharge duration. Rest others are in Japan. All other countries are using only lithium-ion batteries.
So that means in now, if say suppose today if I go to any NTPC power, what is a substation, so I will find this lithium ion battery bank also there.
Yes, some places it is there. Means they have started with small units, not very big units, but they are there. Means I think in this slide I have not put this. There is one association in India, IESA, so India Energy Storage Alliance. So you can go to the site of that, and there is one report, Energy Storage 2030 Vision. In that they have provided the details of existing, how much energy storage is available in India right now, and in that they have mentioned NTPC also they have certain plants where they have small battery storage. So they started as a pilot projects. So now they will, even big storages are also planned. Just like I told you that in Leh they are planning a very big energy storage for evacuation of this huge solar output. So they have found that instead of building a new transmission line, if we use storage, we can avoid building one transmission line. So instead of 10 MVA transmission line capacity, we can have 5 MVA transmission line, and rest we can have 13 gigawatt hour of storage, which can avoid erection of one transmission line. So that is also capacity investment deferral. So storage has several use cases, and these things around the world there are several examples of storage. Even there is one application, we call it storage SATA. It is called storage as transmission asset. So in this, storage can provide several type of services at transmission level, such as investment deferral. Just now I have told you. Another is congestion relief. It can help in relieving the transmission line of congestions. And all other services also there, angular stability and transient stability. These things are there.
Basically, if we say that in that now substation there is a storage battery bank with connected with the inverter to the grid. This is the layout.
Yes, it is connected through inverter. Okay, so let's move ahead. So one purpose of the energy storage is because of this renewable, to ensure that to reduce this intermittency of these renewables and firm their output, reduce their curtailment of excess renewable generation can be stored in energy storage and which can be used later. Then this history of energy storage was discussed, then classification of energy storage. So what are the different types of energy storage available? Can you classify? I think using 5-6 classification.
Mechanical, electromechanical, then
electromechanical is not there.
Like super capacitor, they are electromechanical. Sorry, electromagnetic. Sorry.
Yes. Yes. What else? So mechanical
and hydro.
No. It will come in mechanical. One is chemical. For example, is hydrogen or synthetic fuels. Ammonia is also being considered as one of these storage for chemical storage, because we are already using ammonia in industries. Handling ammonia is easy. We have experience of using it for several decades, so ammonia is also being considered. Then, what are other example, other classifications? Mechanical and electrochemical. These batteries, different type of batteries. And one more is thermal. Then hybrid energy storage also you have seen.
Thermal, what is the example? Thermal storage?
Thermal, one is this molten salt based solar concentrators. There is one very big plant in Morocco, I think, 700 megawatt or 6 or 700 megawatt. That is a molten salt based plant, energy storage. So there are solar concentrators. They use solar concentrators. So that concentrator will concentrate the solar irradiance onto a particular on a fuel. It will heat that fuel. Since it's a salt here, so it will be heated. The salt will be heated. So it is converted into molten state. And then it is able to hold that heat for a long duration. Thermal main advantage is that the energy is stored in this heat form. If we are able to increase the temperature to 1000 degrees and maintain that, then energy can be stored for several hours. And then whenever required, steam can be produced.
In India, it is there?
No, in India we don't have thermal storages.
Where you said 600 megawatt, Morocco?
Morocco, yes. It's called Noor. The project name is Noor.
Noor. Okay.
And there is one more project. It's not that big. It's called Sand Battery. The country is Netherlands. There is one company which has come up with this concept of sand battery. They will heat the sand to very high temperatures. And then because these Scandinavian countries in winter especially, they are very cold. Temperatures go below zero degrees. They require this heating. Heating requirement is quite huge. So if instead of drawing power from the grid, if we can somehow manage to meet those heating requirement by some other source, then that's very good. That was their main idea. So if we can store this energy in sand, heat the sand to very high level so that it can be the heat can be captured for several hours, and whenever required, the steam can be produced and directly it can be used for heating purposes. So steam or hot water is used to heat the houses, to keep the houses warm. Even in industries also, some industries they directly consume heat. They require steam for industrial processes. So there also thermal power plant, these thermal storages can be used. So there are some new companies coming up especially for this industrial purpose, for industrial processes. So combined heat and power plant can be converted into a thermal storage. So these are examples. Then these examples we've already discussed. In Australia there is this Victoria Big Battery. It's the name of that project. It's around 400 megawatt, 400 megawatt by 1600 megawatt hour. So 4-hour discharge duration is 400 megawatt. Then these are the hybrid energy storages. So why do we go for hybrid energy storages? What's the main reason? Why are we combining these two types of energy storages?
Because of the different rates of delivery of power.
So one good example that I can give you is of a automobile or a car. There is one company, I don't remember the name of that company. They use that's a completely fully autonomous car, self-driving car. You just have to sit and indicate where do you want to go. It's voice controlled and it is powered by supercapacitor and a fuel cell. The problem why they've considered these two. Why cannot we go with only fuel cell? The problem with fuel cell is its response is slow. It cannot immediately provide power. It cannot supply that immediate. It will take few seconds. But supercapacitor is very fast, very quick. Initially, when we want to start any automobile, we require huge torque. Torque requirement is huge. Power requirement is high. So that requirement cannot be met by using a fuel cell. That requirement is provided by is met by the supercapacitor. Supercapacitor can provide. They have very high power density. So they can provide immediate power within milliseconds. But they cannot store energy for a long time. That is why there are these two types of energy storages. One with high power density and another with these high energy density. So high energy density energy storages they can discharge, they can provide energy for a longer duration, but they cannot immediately provide high power requirement. That is their characteristics. Similarly, high power density, they have very fast response.
So in that you have written battery and last is super capacitor, which is opposite, na? First you have
correct. Yes, correct.
First super capacitor and hydrogen, and the last you said battery and super capacitor.
Yes, this is correct. It should be reversed. Supercapacitor should come here and battery should come here. Correct. Good. Similarly, this fuel cell also, I have interchanged these two. Fuel cell will also come here. High power. No, this is correct. Fuel cell is correct. Sorry. Battery response in comparison to fuel cell or compressed air energy storage or supercapacitor is supercapacitor. In comparison to these two, battery is fast, quite fast. Within millisecond also it can work. But compressed air is it's slow. Fuel cell even slower than fuel cell. Compressed air is a mechanical system also. Then there is this other example of lithium ion and vanadium redox flow. Why we use lithium ion? And there is one example of this is one in Australia, and there is one more in I think Oxford. In Oxford campus, they have installed one lithium ion and redox flow battery hybrid energy storage, because problem with lithium ion is its degradation. Frequent charging and discharging cycle degrades the life of this lithium ion battery. On the other hand, vanadium redox flow battery is not affected by that frequent charging discharging cycles, because its construction is little different. In flow batteries, they have tanks in which electrolyte is filled. Even if the quality of electrolyte is deteriorated, we can remove and fill it again. That is possibility for redox flow batteries, but for lithium ion this is not the case. Once it is degraded, we have to replace the entire battery. That is why, to prevent the frequent charging discharging cycle of lithium ion, for redox flow batteries are used. Whenever frequent charging discharging operations are required, that operation is performed by these flow batteries. And once those are done, constant supply is required, lithium ion is used. So here the main reason is to avoid the degradation or reduce the degradation of lithium ion battery. And here the main purpose is to meet different kinds of requirement. So depending upon the application requirement, we can have different combinations of energy storages possible. Here is example in US. So this is supercapacitor and battery. We are using it for renewable smoothing. So for smoothing, intermittency is sometimes it's quite frequent. So that frequent operation, again, it can be supercapacitor can provide those frequent operations. It can supply power very frequently and within few means very fast also. Then lithium ion and hydrogen for grid stability. Hydrogen, its power density is not that high; it's very low, but energy density is high. So hydrogen can provide very long discharge durations. That is why this hydrogen has been considered as a seasonal storage. It can provide discharge duration more than 100 hours. And one example is this sodium sulfur and lithium ion for frequency regulation. Okay. Then we discuss this battery modeling methods. There are three methods: electrochemical, equivalent circuit, and empirical method. This is the equivalent circuit for a battery. It's a two-time constant representation because of these two RC blocks. We can have several. The more we increase, the better is the performance of the model, and better will be the estimation of state of charge. But the more RC blocks we include, the more the computation burden increases, because nowadays everything is online. So everything is done online. Online estimation is done through cloud. If the model is very complicated, it will take time to solve that model. So we want a fairly adequately accurate model. Even if accuracy is not 100%, we want a model which can provide quick results. That is why researchers have found out that this is quite a good balance. So they have come up with this two-time constant representation. We can have one-time constant representation also, but then the accuracy will further reduce. Whenever we want to see dynamics of energy storage, then we can use this RC blocks. If we are not concerned about dynamics, we are only considered about the steady state, we can even remove these. We can directly consider this block only this much. The RC block will help us study the transient behavior. So if it is not of our interest, we can avoid these also. So depending upon the type of analysis which we are doing, the type of estimation you want to do, the models are also used or changed or modified. Then we look into this battery management system. These are the different functions of a battery management system. Battery management system is a very important component for any energy storage system. Without it, it is not possible. Nowadays, you would have seen that several two-wheeler, even four-wheeler are also catching fire. Electric vehicles. Have you seen or heard of this?
Yes.
So what do you think is a possible reason for that? What could be a possible reason?
I think thermal management.
Yes, correct. So what happens, especially in two-wheelers, this has been found in two-wheelers much more than four-wheelers. So what happens in two-wheelers? Already the battery cost is high, and they want to reduce in cheapest. They want to produce that two-wheeler in cheapest cost, minimum cost. Half of the cost goes into battery itself. If not half, at least. So if you buy a 1.25 lakh, I think it was around 1 lakh's e-bike, around 36,000 was the cost of battery itself. So it's only 37% of, maybe, let us say 40% cost is battery itself. So to reduce the costs, what they will do, the battery management system which is there associated with the battery, they will invest less in it. The thermal management system is not that good. It is of not good quality, and because of that it is not able to contain the temperature of the battery, and then battery simply it explodes. It's very important for lithium-ion battery. Not just battery, for any other inverter, converter also, the cooling system has to be very good. Especially for this lithium-ion battery, it has to be, the thermal management system should be very good. The main reason for all these vehicles catching fire is this thermal management system, which is poorly designed. Because they want to reduce the cost. Especially what happens, most of the cases which we have found is that once the vehicle is used, it is parked in sunshine. In daytime, when this irradiance is quite high, the battery is already heated because of driving, and then there is further increase in temperature because of surroundings, and the thermal management system is not able to cope up with the increase in temperature, and then this problem happens. Because of this, several companies, they have changed their thermal management subsystem. Now these cases are reducing, but still we can find some of them. So BMS, the battery management system, plays a very important role in this, and one of the function is thermal management. Even whenever the vehicle is manufactured, especially these four-wheelers, even two-wheelers are also undergo these tests. The four-wheelers, they will go under all the different kinds of tests, pressure test, stress test. So the battery will be crushed. If suppose there is an accident and the battery is crushed, it should not explode. So all these type of tests are conducted. One time I think Tesla, this was Tesla Model S or T. So it was started it was right on the top of around Rocky Mountains. The car was allowed to go down the hill, and while going down, it caught fire. So this was a test. No one was sitting inside it. It was just a test. But it caught fire, so they had to change their strategy. Something is wrong. So all these things are done because
all these electrical buses also has lithium ion battery.
yes.
So that means every vehicle which is electrified, the EV battery, what we say is lithium ion only, not nickel cadmium.
No, right now we have all lithium ion, and these these 3-wheelers, we have these e-rickshaw, they have lead acid battery. They use lead acid battery.
Why they are not using lithium ion?
Because of cost. Main reason is cost. And they use BLDC motor. So both of these are used to reduce the cost. And these 4-wheelers, they don't use BLDC motor, they use this EMSM, permanent magnet synchronous motor, or some of them also use induction motor. Some of these e-rickshaw also have the solar panel on their roof, so they can charge. That is a good concept. Okay, so these are the function of battery management system: to measure current, voltage, and temperature of each cell, and they have a monitoring IC, which can provide these measurements: voltage, current, and temperature. Which then the sensed temperature or measured temperature goes to this thermal management block, which will try to keep the temperature within its range, the permissible limit. Then cell balancing is a very important. It's very important to keep the cell balanced. Unbalanced, if cells are not balanced, then it will reduce the efficiency of the energy storage system. It highly impacts the efficiency and overall performance of the energy storage. Then we have to estimate state of charge and state of health. It's also very important. Why do we need to know about SOC and SOH? Can you tell?
Because while discharge, we should not discharge the battery fully. At least 20% it should be there.
Yeah, that is there. And what are the other? If you see, suppose you are driving a car, would you not want to know how much more distance you can travel with the present state of charge?
That is what we have to maintain at least 20%. Don't charge the battery fully.
Even if they already have that inbuilt, so they will, because the battery, they know, the manufacturers, they know that they cannot over discharge the battery or even overcharge the battery. So inherently they have kept that limit of 20% or 10%. It depends on the manufacturer, 10 to 90% or 20 to 80%. So they also keep this limit inherently inside. Sometimes you will see, even when we are using laptop, 5, 7, 8%, even after reaching 8%, it will close automatically. Although 8% is there, but still it is gone. So they are inbuilt, they have provided these restrictions, we can say limitations, to avoid over discharge and overcharge. They have circuits which prevent this overcharging of the batteries. Otherwise, if we are using a car, and if suppose the user is doing frequently overcharging of the battery, then and if the manufacturer is not taking these things into account, then the battery will degrade, and the half of the cost of the car is of this energy storage, this battery. then no one will purchase from that manufacturer. So that is nowadays the Tata, which is the model of the EV model for Tata?
Tigor and Nexon.
Yeah, Nexon. So for both of them, they are providing around, I think, 8 years warranty for battery. So 8 years it's a long duration, because they have kept all these things into account. Otherwise, customer satisfaction is very important for them. Otherwise, no one will purchase, because they know that if the battery is degraded, then within 3 years I will have to invest again 7 lakh rupees to buy a new battery to replace that battery. Car was 14 lakhs. 7 lakh after 3 years again. Every 3 years I have to spend 7 lakhs. Then why would I buy that car? So all these things are taken into account, but still we should not over discharge the battery. We will see one curve. I will show you one curve, how the depth of discharge affects this life of the battery. More the depth of discharge, more is the degradation of the battery life. So it is always advisable to not discharge the battery too much. Keep the depth of discharge as less as possible. The next is this computing energy and power limit of the pack, thermal management, and protection against any kind of short circuit, overload, deep discharge. Deep discharge, overload, overcharge, and short circuit. These are also very important. And then another important thing is external communication, data logging, and status display. So we see on that LED panel that we have in front, it will display what is the state of charge of the battery, what range it can provide with this state of charge, what is the temperature. Even sometimes they show temperature also. So all these things we can see clearly. These are the status. Then they also have these data, keep on storing certain data, and if it is connected to cloud, they can also share the data to the cloud, so that any kind of if mal-operation is there, they can diagnose it. Diagnostic tool is also there. It can run and see what was the problem, what thing went wrong. This happens through external communication. Now these are some of the advances in BMS system. One is wireless battery management system. So all the battery packs, they communicate wirelessly with the other modules. So cell balancing is done using this wireless communication. These are the advanced BMS which have come up recently. Then smart BMS, well, they will display each and everything, all the analysis, entire battery performance can be visualized using the apps. So this, and then AI powered digital twin cloud BMS. So this digital twin concept we discussed in last class also. Anyone of you, do you remember this? What is digital twin?
You have given example of windmill wherein the closed loop control is done by digital twin.
Yes, so digital twin is this virtual model of that physical asset. We have actual physical windmill, same entire physical model, that virtual model governing all the equations governing that physical model is built in that model, and that is on a system, and they take input from the actual physical asset via the sensor, which communicate through this communication and infrastructure. Then they will run whatever control is there required, and they can also send back any action to be taken. They can again communicate to those sensors or actuators which will take the actions. and if any required. Similarly for BMS also. Now it is happening for several other equipments also. Digital twin is a very recent concept and now it is being widely used. You can see, and you would have, I think not, in movies you would have seen. There is one, doctors, they operate on a virtual heart and they will perform the actual surgery which they have to perform on an actual patient. Entire surgery they will perform on that virtual heart, which will exactly work as the patient's heart. And if they are able to successfully conduct that surgery on that virtual heart, they know that they will be able to do that on that actual patient also. That is also AI mod. That is also a digital twin. Although here we are not communicating anything, we are not taking action. It's not a closed loop system. It's an open loop, but it is very helpful. These things are widely being used nowadays. Then, this is cell imbalance. These are reasons for cell imbalance. These are leakage, self-discharge currents, efficiency because of conversion from storage medium to electricity and vice versa. Then uneven temperature also results in cell imbalance. Internal resistance. No two cells have same resistance. There is always slight difference. That also results in cell imbalance. These are reasons which we cannot avoid. So we have to deal with them. Somehow we have to balance these cells. For that we use different types of mechanisms techniques to balance the cell. And why is it important to balance the cell? Anyone can answer?
If the cells are not balanced, then internal current will flow between the cells.
Yes, internal current will flow and also
So that will increase the temperature of the cell
further.
also.
So it is a loop. Even uneven temperature is causing cell imbalance. That will cause internal heating. That will again increase temperature. And it will just keep on increasing temperature. Other reason is that cell with less capacity, it will discharge faster than others. And if two cells are connected in series, one with less capacity, one with more capacity, if one of the cell is deteriorated, the entire string will not be able to charge or discharge.
How to measure the cell imbalance between the two cells? What is the limit?
What is the limit?
If a battery has 18 cells, okay, suppose. So I have to find out these 5 cells are not equally charged. So what is say suppose the good cell is 2.1 and the bad cell is 1.8. So voltage is one of the what you say criteria. And any other criteria?
Energy. How much energy is stored in that cell? So these are the two things. So based upon these two, we have these two types of strategies also, techniques also. One is passive balancing and one is active balancing. In passive balancing, we are trying to equalize the voltage. The cell which is having higher voltage, so across each cell, one resistance is connected, and cell with higher charge will be higher charge will bleed or will be dissipated into that resistance, so that the voltage reduces and it becomes equal to the other cell's voltage. So in passive balancing, we are trying to equalize the voltage by discharging these cells with higher charge. So this is resulting in dissipation. Is it correct?
Yes.
Yeah. So, and second one is the energy balance. In this, what we are doing, this energy, the cell which is having higher charge, that energy is of no use. It is being wasted. It is simply being dissipated in that resistance. Instead of that, what we can do, we can use that energy to charge the cell which is having lower energy. So that happens in the active balancing. There is exchange of energy between the high capacity to lower capacity cells without dissipation. So which one is better? Active or passive?
Active is always better.
Yes, active is better because here we are avoiding loss.
So this active circuit is in between the battery, na? It is inside the battery or it is external to the battery?
It's external. So for each pack, it was also shown, and I don't have that picture. I have not put that picture here, but in the lecture it was shown. All these modules have external to them one cell balancing circuit. So these cells are connected in the series parallel combination. X is vertically and horizontally, they are connected. And for each module there is one cell balancing circuit. And there are different configurations for that also. Few cells, one string may have one balancing circuit, one entire module may have one. There are centralized topology, decentralized topology, hybrid topology. So that all depends upon the manufacturer. So different types of techniques are there. One module can have even one string can have one cell balancing circuit. There are different configurations possible. Yes, so one question is this: why are we using battery? We have other type of energy storage also. Why is battery so popular?
Battery technology is mature and it is easy to maintain batteries and it is small scale. Maintenance is also there. So a lot of advantages are there with that.
Pumped hydro is there, it's quite mature.
No, but the pumped hydrogen is a very large setup. You cannot do it in a small setup. So flexibility of small setup is with the battery.
Yes, that we call as modularity. So that is correct. Batteries are modular and that makes them flexible. Anywhere we can place those batteries provided we have the space. And they don't require that much space. If you want to construct a pumped hydro storage of same energy and power rating, then the space required for pumped hydro storage will be quite large as compared to the battery. And also that is why they have this they are geography limited and also limited by the availability of water. There are different types of two types of pumped storage, open and closed. Closed we can have anywhere, but still we should have a place for that, we should have a space for that. And open are those, they should have a reservoir nearby. Closed one don't require any reservoir. But you have to construct two reservoirs and have water in them, and then just transfer the water from one reservoir to another. But open one, they are always connected to a flowing water is there. So river may be there, canal may be there, and another reservoir will be there. So they too will exchange the water. So mostly we have these open kind of pumped hydro storage. There are some closed one, but not many. Battery's response is also very. They can quickly respond. The ramp rate is high. Easily we can scale them, transport them. Even we cannot transport if we have a pumped hydro storage at a place. Can we move that pumped hydro storage to another place? That is not possible. But with battery it is possible. We can have mobile batteries. That is possible. There are some few papers on that also. We can transport the battery energy storage to one place to another if required in emergency situations also. That type of thing is also possible with battery, but with other storages it's not possible. It's difficult, especially for these hydrogen, compressed air, pumped hydro. They are localized. Once erected, they cannot be moved. There is this battery called Gemini battery. They have given it a name. Its inventor is our next energy. So they have placed this battery in a car. Right now, what's the maximum range which you can have for a car? If you have any idea, any guess?
I think 300 kilometers.
We can have more than that also. Even that Hyundai Kona, it has a range of around 425, I think, or 450 kilometers. We have some few cars with range of around 500 kilometers, but not more than that. So they have come up with this battery. So it's a combination of two chemistry of lithium ion only. Lithium ion, there are different types of chemistries available, and they have different types of different C rates. So one is, they are using two chemistry. One is LFP, lithium phosphate, another is LMO, lithium manganese oxide. So for first 240 kilometer they use one chemistry, and for the remaining they use the different chemistry. The combination of these two, they are also reducing the requirement of lithium and also graphite, and it's providing a range of around 1000 kilometers on full charge. So several new things are coming up. Have you heard of nuclear battery?
Nuclear battery, first time I am listening. Please explain that.
Even I don't know much about that, but so I have heard that nuclear battery, it's just a concept right now. And some of them, small prototype has been developed in one of the labs. So they claim that once charged, just as we have these radioactive elements, uranium is there or some. So their radioactive decay, their life cycle is very huge. So you will work.
It will never be practical because it will be having, if suppose someone discharge that battery with a pound, that pound will go. Okay, so with that
Pound
means that water contamination and all. Yes, so suppose today if I have that nuke battery and I dispose it of in a small river, the whole river will go. It will never happen.
Yes. People, they come up with all these things. They keep on doing something. They don't think about nature much. Yes.
No, but once it cannot be commercialized.
Yes. Still, people, they do keep on doing something or other. One is paper battery. You would have heard of paper battery.
Yes, paper battery I have heard, but what is the application that I am not?
Have you heard of these? Even there are Samsung and all these companies, they are researching for on these mobiles. They want to reduce, make the mobile very thin. It's thin
Just
like a paper.
Just like we have a calculator, we have a PV cell. It is a paper like cell.
Yes. Similarly, they want to make mobiles which are like this paper. You can even you can wear those mobile on your wrist. These are not very firm like a cardboard thing. These are organic, just like OLED. Have you seen OLED TVs are there right nowadays? You can even fold them like chart. So such type of mobiles they are planning to bring. So they are very thin, and in those mobiles you will need these paper batteries. These are futuristic kind of things. Very futuristic. Similarly, there is one more technology, eVTOL. So it's a e-taxi, also e-air taxi you can say. So it's a air taxi based on fuel cell or hydrogen. All these things are coming up. Now we'll start with these questions. First question is, which of this is not an electrochemical energy storage? So which one is the correct option?
I think it is C.
C, sir.
Are you sure? Yes, D is the correct answer.
D is the correct answer.
Because these three are batteries. Or they work on this vanadium redox flow batteries. They work on redox reactions, and they also work on this electrochemical reactions. Synthetic fuel, they have a different mechanism, similar to hydrogen fuel. Next question is, two battery aging phenomena are. Which are the two aging phenomena? Which option is correct? Conditional and cyclic aging, conventional and calendar aging, calendar and inherent aging.
D is the answer. Calendar and cyclic aging.
Correct. So, do you know the difference between the two?
Again?
Can you tell the difference between the two, calendar and cyclic aging?
Suppose now if we in our car also we have to change in three 3 years is a calendar battery life.
Correct.
But now if you are doing discharge more cyclic discharge, so it may go up to say suppose 1 year also.
Correct.
That's why it all depends upon the cyclic discharge as well as calendar also. Which is the least it is the life is like that.
Yes, so calendar is inherent and cyclic is, with every cycle there is a degradation of the battery. And cyclic life depends on, correct. And calendar life means cyclic life. So we'll see here. So battery degradation is of two types. One is calendar aging. That's inherent degradation, which is capacity fading, increase in battery resistance over a period of time. It will happen. Even if you don't do anything, it will happen. Second is cyclic aging. It is due to charging and discharging cycling. So with every charging and discharging cycle, there is degradation of battery. If we do more frequent charging discharging cycle, the life will reduce. And it depends upon all these things. Depth of discharge rate, limits on SOC and ambient temperature. So this is the curve which I was talking about. So here you can see. So these are different C rates, charging or discharging rates. So here it is discharging only. So if this is 5C. If we discharge the battery with a higher rate, then the life will reduce. The degradation will be much faster. Similarly, as the depth of discharge increases, every time we are discharging the battery to 100%, then the life will be only this much. Its actual life is around this much, 5,500 cycles. But if we are fully discharging the battery every time, then the life will be only around 500 cycles. So it depends on both depth of discharge. More the depth of discharge, more is the degradation of the battery. Similarly, higher the charging and discharging rate, higher is the degradation. So it's a function of both depth of discharge and charging rates. The discharge rate, you can say.
But sir, if we take our example of a car, in which the situation will never happen that we can discharge to 100%, because whenever we are driving, automatically charging is there.
Yes.
So,
you are correct. If
only one crank what we take initially is discharging, and then it is always charging whenever we are moving. So in that scenario, is the life is increasing of the battery because we are never discharging?
Yeah, so whatever it is designed, suppose it was initially designed to continue for say 1,000 cycles, and if we are not discharging it much, so it will continue for 1,000 cycles, and if we discharge it more, so it will continue for maybe 600 cycles only. So
in my example, what I said, in car, I have never discharged to 100%.
Yeah, so if it was meant to,
and I have never charged also, because it is automatically charging whenever we are driving.
Yes.
So in that case, number of cycles has no significance.
No, significance is there. If depth of discharge is very less, then it will work for its desired time. Suppose it was designed to work for 3 years, and if we are not discharging it much, then it will work fine for 3 years. It will not create problem. But if we are discharging it more, then it will even before 3 years we will have to replace the battery. That is the main thing here. And sometimes happen, many people, especially those who are not frequently using the car. Sometimes the car is there and they are not using it for even 1 month, 2 months. Then it automatically self-discharges there and it discharges. Then we have to push the car. It also happens. So it depends upon the usage. If the car is not being used much, then it will self-discharge. Because we are using these lead-based batteries in cars. Those petrol cars, they use lead acid batteries, and their self-discharge rate is high. Lithium-ion self-discharge is quite less as compared to these lead acid batteries. Therefore, even if we are not using the car for 1 month, 1 or 2 months, then it discharges completely. So if we are frequently using the car, every day we are using, then this problem does not arise. Is it fine?
Yes. Next question.
Yes. So this is a C rate. C rate is a measure of rate at which a battery is discharged relative to its maximum capacity. So if 1 C rate means that discharge current, the battery will discharge entirely in 1 hour. So if 100 ampere hour battery is there and if discharge current is 100 amperes, it will completely discharge in 1 hour. And this C rate depends upon the battery chemistry. Not all the battery chemistry will not support these. That's why the fast charger which we are looking for, we want that our car should be charged within 10 minutes. Like within 6 minutes, 5-10 minutes. For that we need these fast chargers, fast DC chargers. So the battery chemistry should also allow that much current to flow at every instant. So for that there are these chemistries like LTO, lithium titanate oxide. It has a C rate of around 10 C. That means within 6 minutes you can charge. Depending if the rating of the battery as well as the charger is same, then within it's possible. DC charger we are using because no conversion is required. Battery is also, it consumes DC power, it gives DC power, and onboard charger is a AC charger. But if we put an onboard AC charger of a very high capacity, high rating, then the weight of the vehicle will increase and the cost will also increase. The space required will also increase. Everything will increase. That is why we are not having these big chargers on the vehicle on board. We are having off-board DC chargers, very fast chargers. And the advantage is also there. We don't need a AC-DC conversion stage. That charger is also DC. Batteries can also be directly charged with DC. So we can have a direct charging.
But if that battery is not designed for that fast charge, then it will explode. So is that criteria of a battery? It is written somewhere that it cannot be charged more than 4C or 2C. Is there any criteria?
Means it will not explode because they are designed in such a way they have a current limiter.
Like ampere
they have a current limiter or circuit inside.
No, my point is like ampere hour is written on battery. So is the 1C, 2C is also a parameter of battery?
For each battery it is provided. Each manufacturer they provide that detail also. That is it.
Okay.
Yes, this question is done. Next is this. Which of the following is not a firm generation resource? Which is the correct option?
D is not firm. Rastol is base plant.
Correct. So this is not firm. Solar, wind, these are not firm. They are intermittent generation resources. Next, which of the following can help mitigate seasonal imbalances in load and generation? I think we discussed this point today.
It is pump hydro, and ABC is the answer. However, D is not the answer.
ABC, you are saying ABC?
Yes.
See, means again, see this word, seasonal. Anyone else would like to answer this question? C, pumped hydro. But any other option? As per research, it has been found that lithium ion we cannot go beyond 10-hour discharge duration. Beyond that, it becomes highly uneconomical to construct a lithium ion with more than 10-hour discharge duration. So right now we are only having 2-hour and 4-hour discharge duration lithium ion batteries. So maximum we can go only up to 10 hours. So seasonal imbalances requires more than 100-hour discharge duration. So lithium ion cannot provide that. Lithium, so there are 3 types of discharge energy storages. We can classify energy storage based upon this discharge duration into 3 types. One is short duration, long duration and seasonal. Sometimes they combine these two also. So they say less than 12 hour short duration and more than 12 hour long duration. So combine everything in long duration. But if we further classify, then this is the classifications up to 10 hours discharge duration, it is short duration. So these lithium ion battery comes in this. Flow batteries. Flow battery can also, some of them can provide. But metal air batteries. So metal ion batteries. They have more than 10 hour discharge duration. There is one company which has come up with this metal ion battery, which can provide a discharge duration of 100 hours. I think it is zinc ion. Not remembering. I have that slide not here in this slide deck. So this is long duration energy storage. So pumped hydro, compressed air also belong to this category. So they can provide up to 100 hour discharge duration. And more than 100 hour hydrogen. So much work is now being done on hydrogen. Even Indian government has also come up with this National Green Hydrogen Mission.
Normally, in the power system, power load, we take 24 hours. 24 hours is the maximum. Okay. Maximum peak load day-wise we say, which is divided into 15 minutes block. So now, if we say 100 hours, so that means it is taking care of, say, suppose 24 into 4
more than little more than 4 hours.
More than 4 days. Than 4.
Sorry, 4 days. Yes.
So suppose some power plant is or nearby power plant is unsuccessful for 4 days, then this long duration storage will help.
Yeah. So this is where this will be required is right now we have this our energy mix. We see generation mix. 60% generation is still even 65% up. Nearly 60% is still from coal and only 40% is from other resources. But the targets which we have, this seasonal energy storage is not required now. Even in near future it will not be required. It is highly futuristic scenario. The target which we have, especially countries which have target of 100% renewable energy system. That means 100% solar and wind, or some biomass will also be there. But 100% solar and wind means it is fully uncertain. Suppose if in winters there is the irradiance is low, even it happens that during winters when temperature is same all around, even nearby places, the pressure difference is not there, so wind is not blowing. Wind may not blow. So let's say for 1 week the wind is very less. Then what will happen? What are we going to do? Because we don't have coal, thermal plants. We don't have thermal plants. We have only solar, and solar works only in daytimes. In night time, especially in those areas where the winter is too harsh, they need this heating requirements, and the heating requirements is mainly during night time when solar is not there. Then it will be very difficult to meet the load. So these seasonal energy storages are not being required now, but after 30-40 years when the grid will be entirely renewable base, then we will certainly require these energy storages, seasonal energy storage, which can provide these more than 100 hours of discharge duration. So you're correct. Right now we don't need them. Even 2 or 4 hour battery storage are sufficient. That is why the CE is also planned for the 4 hour battery, 4 hour discharge duration battery storages for 2030. Around I think 40 or 60 gigawatt. It is there in the report, the transmission planning report for 2030. They have also planned for energy storages offshore wind plants. So it's certainly true that it's highly futuristic scenario, but we have to plan for future. That is why we are so much work is being done on hydrogen. Is it clear?
Yes.
Okay. So this is the hydrogen energy storage system. It has 3 parts, 3 components. One is production of hydrogen using electrolysis. Why is it called green hydrogen? National Green Hydrogen Mission. What is green here? Why is it? Sorry, we could not hear.
Renewable energy for electrolysis process.
Correct. So this hydrogen is being produced from renewable energy. So these hydrogen energy storage systems will be also having an adjacent solar or wind farm, or even a hybrid solar wind farm. So they will, when excess renewable generation is there, they will produce hydrogen. Then storage of hydrogen, because it may not be immediately required, so it will be stored, and then whenever it is required, it will generate electricity using these fuel cells. So during winters, if generation is low, then they can produce.
These fuel cells are equivalent to the LPG cylinders. Can we say like this? Like
these are different. They will use hydrogen and oxygen to generate electricity. It's a reverse of electrolysis. In electrolysis, what is being done? Water is break down into hydrogen and oxygen. Fuel cell reverse happens. Oxygen and hydrogen will combine to produce electricity in water. That is why so much work is being done on these fuel cell based electric vehicles also. Now there are, I think I have one slide here. The next slide. This is a National Green Hydrogen Mission of Indian government. They want to support this domestic manufacturing of hydrogen. That's why they are providing incentives for green hydrogen production, and many companies are now coming up with these green hydrogen plants. In several industries, they need this hydrogen, and they can use that. So yeah, I was talking about this. So this is electric truck. Even hydrogen-based car is also available now. So UK has manufactured this electric truck. Even I think one electric train has also been started somewhere in one country, Germany, or it's hydrogen-based. So this truck has a range of 500 kilometers, and it's using lithium-ion and hydrogen. And hydrogen is being used for range extension. So it will keep the battery charged. And now this Airbus is also planning to build first hydrogen powered aircraft. Even one company has already started. It is a smaller aircraft. I think 40 passenger capacity is 40 passenger can sit in that plane aircraft. They have run it using hydrogen. next 10 years we will see car, train, trucks, planes, all of these working on hydrogen. And for that we need entire hydrogen infrastructure. That is why government has started this National Green Hydrogen Mission, so that we have that capacity to produce green hydrogen. And for that we need, so that is why one in previous session, last to last session, someone was asking about multi-vector system. So this is an example of multi-vector system. Here hydrogen will require energy, electricity for electrolysis, for production of production of hydrogen, and then it will also produce electricity. So that electricity it will take from either from grid or it will have its own plant. So now we want to plan for both hydrogen and this electricity network and hydrogen network has to be planned together. This is one example of multi-vector system where we do we can say integrated planning of gas, hydrogen and electricity network. This is also being done. So research is being done on integrated planning of gas, hydrogen and electricity. And fourth is thermal also, because thermal storage will also come up. So these four things. So we need to plan them together. Where should we locate hydrogen power plant? Where should we have the thermal storage located? So all these things, so that entire integrated network is optimal. Minimum cost, minimum investment is required in that. What will be the optimal location for each of them? Where should we lay the pipelines? So all these things, it's a very big problem. So it's an example of classic problem of multi-vector system, or we also call them multi-energy system. Next question, this is done. Next question is, what does the capability curve of energy storage describes? What's the
A
is not correct. Anyone else would like to try?
B
is also not correct. Now only two options are left.
Then D is the only answer.
D, yes. D is the answer. So in lecture you would have seen this type of graph. Here we have P, Q. Now, this is Q. This is P. Now if I want to operate at constant kVAR, what will be the operating region? This curve decides the operating region of the energy storage, and the operation will further reduce the region. This is the permissible region where we can operate. And if you want to operate at a constant kVAR, suppose
parallel to the P line.
Correct. Suppose this is 500 kVAR. So if I want to operate at 500 kVAR, then these are the only points that I have. This line. I can only operate on this line. Similarly, if I want to operate at constant power factor, then what will be we call it locus. What will be the operating region? That will also be a line, but will it be parallel to P axis, Q axis, or not parallel to any of the axis?
It is line from 45 degree to the passing from origin.
Not necessarily 45. It will depend upon. It will be 45 only when P and Q requirement both are same. The power factor at that time will be cos And it's 0.707. Because cos phi is not 0.707. It's P by S, so it will be P by root P square plus P square. If you want both same, then it will be P by root 2P, so 1 by root 2. It's correct, so 0.707. So depending upon the power factor that we require, the line will be. If it cos factor is 0.707, it will be 45-degree line. Otherwise, its slope will be determined based upon the power factor. Lagging or leading, that will also matter. So line will be something like this. It will pass through origin. Line will pass through origin. And the slope will be determined based upon the power factor. Correct?
So this battery is also like generators, ideal power factor is 0.8, what we say.
For
So
generator?
For generator, ideal power factor is 0.8.
Okay.
So what about why it is 0.707 in this case?
No, it's not 0.707. It will be 0.707 only when the battery is producing P, which is equals to Q. Since both active and reactive power are same. At that time, PF is 0.707. But generally, P will be more than reactive power. No? Generally, when it is discharging, generally P will be more than Q. It will depend.
Ideally, if you see the generator power factor which is written, it is 0.8. Generator power factor is 0.8 ideally, which is written on generator also. Okay. Why we are not keeping this battery also 0.8? That is my question.
It depends what we want to do with the battery. Battery can provide numerous applications. It all depends upon the requirement. What we want to do from the battery. The generator is a mechanical device. It has several limitations. But battery is little different. We can do much more with a battery because it has an inverter which provides us a lot of flexibility. But disadvantage is that it cannot provide this inertia. But there are also some virtual inertia models. So that is why battery is more flexible in that terms.
No. For battery 0.7, what we said is good.
No, it's not. It's not good or bad.
It is feeding active and reactive power equally.
So equally
it is good. And in that system, active power generally people give, but reactive power people don't put. So that is why the problem is there. So it is good for the grid to have reactive power more. That is
no, not always. Not always. Suppose at a bus, especially in distribution system, when we have this problem is there during daytime. When solar is there, the voltage goes beyond 240 volts because of solar injection. At that time, if we inject more reactive power, then voltage will further increase. So if there is a solar plant at a transmission level and during daytime it is feeding more power, then the voltage at that node will increase if it also feeds reactive power through its inverter. So it all depends upon the requirement from the grid. So battery is much more flexible. So even generator cannot produce full active power without giving any reactive power. That is not possible for generator. But battery can do that.
Yes, true.
So that is why battery is much more flexible. Generator has that limitation, but battery has no such limitation. D is the answer. Now this is a little trickier question, but I think you'll be able to do. So you have to select the correct option which represent one time constant energy storage equivalent circuit.
Because A is the answer.
Please see carefully. That is the answer. It's little trickier, so take your time, think, and then answer. See all the four options very cautiously.
One time constant means one RC circuit. What I mean.
Yes, that is correct. One RC circuit. So this option and this option is already ruled out.
That is why the RC A is only with that option.
No, you have.
But then it is showing the constant current source. No, it is not showing the voltage source.
Correct. So
None of the above.
None of the above is the option. It's a voltage. It should be a voltage source. It's a voltage source. That's why I said it's a little. You have to think. So last time also I gave this question. Same question was there. So this is the mistake which we do. We have to think each and everything. This is same. Main thing is this source. Is it a voltage source or a current source? Solar PV is a current source, but battery is a voltage source. This is also not correct. It's inductor. E option is correct. None of the above. Then next question is, which of the following are not good quality of cell balancer? Yes. So what's the answer? Karthikeyan has correctly answered this. It's C. Slow equalization. We need fast. We need everything fast, high efficiency, simplicity, and economical. Control simplicity. We want simple circuit. We want high efficiency, but we want fast equalization, not slow. Next is reasons for cell imbalance. We have seen this. Which one is the correct answer? Uneven temperature, self-discharge, intolerant resistance, or all of the above?
All of the above.
Correct. All of the above. You've seen uneven temperature, self-discharge. All these are reason for cell imbalance. So answer is all of the above. Correct. Now this is another question for you.
Fast equalization means that we want all the cells to equalize their voltage fast?
Yes, quickly. As soon as possible. Next question is this. Why linearize the power flow equation for optimization?
Optimum solution?
Even non-linear equation will also give optimal solution. We can get
computational burden is less.
Yes, that is true. As soon as the non-linearities come into the system, it becomes very difficult. Also, in a non-linear system, there can be several maxima, minima. It can be anything. We may be here, and we are minimizing something. We may end up here, although the global minimum is this one. But with linear systems, some linear system will be something like this. We'll always come up here. We know that. So it is called convex. Not all linear systems. There is one question in assignment. So while answering that question, you will know there are certain systems, although linear, but may not be convex. But if somehow we are able to make a convex system, convex function, convex optimization, convex means suppose we have a function. If we draw a line, then that function value below that line will always be less than that function. Means from here to here, this function will always lie below that line. That is a convex. Opposite is for concave. Concave will be like this. Between these 2 points, this function value is always more than this line. So if this is the situation, we always know that the point which we get as the minimum is the global minimum. So we are certain, and we have good number of solvers, techniques available for solving these kind of systems. For non-linear, we do not have any standard solver as such. We have solvers, but it highly depends upon the initial condition. Sometimes it may stuck at a local optima. So that is a problem with non-linear systems, non-linear optimization. That is why, and also, yes, we want to reduce computational burden, especially when we want to take control actions. We want to make quick decisions. At that time, we cannot wait for hours to get the result. For planning problems, we may wait for hours, we may wait even for 1 or 2 days. If we are planning for 10 years from now, we can wait for 1 or 2 days for the optimization problem to solve. But if we want to clear market, we cannot wait for 1 day. We have to do that within few minutes. So at that time, we have to linearize the system because our system is non-linear. Why is it non-linear? Can you tell? Why is it non-linear?
Load is non-linear, parameters are non-linear, everything is non-linear.
Load is linear. Means we assume that load is constant. We forecast it. So it's a constant value. But
temperature, atmosphere, everything is non-linear.
This is our governing equation. Based upon this, from this equation, how can you say that this equation is non-linear? What is causing non-linearity here in this equation?
Vi square.
Yes, Vi square is one non-linearity. Then product of Vi.
Product.
Then this cos, sine and cos terms. Then again product of this Vi and Vj and cos. All these are non-linearities. And solving such a problem, it becomes a difficult problem. But if we linearize it, so that's why in the lecture, the problem of optimal sizing and siting of energy storage was done. So in that, these are equation for distribution system, power flow equation. So after linearizing this, we know the nominal voltage. We also know this Bij, V norm, Gij. These are constant values. So now it's a linear equation. Theta is unknown. All these are constant, so it's a linear term. This is a linear term. This is a linear term. So now it's a linear equation. And we can solve it using linear program if there is no integer variable. And for linear program, we have good solvers. We can solve this. Is it fine?
Yes.
And why are there? There is one question we'll discuss. So, direct cause of permanent failure of lithium-ion battery.
A is the answer?
Yes, it's A.
Yeah.
Yes, correct. So, yes, this is the question. I think this is the last question. And which type of problem is a distribution network planning problem?
it is we convert into linear, but originally it is C.
Correct. See, so why is it mixed integer? Where from the integer variables are coming? Why do we need integer variable in planning problem? This is the question. Why is it integer problem? Connected on off. So on and off is, you can say that it can be 0 or it can be at some value, but on off is not correct.
See, generators, their capacity is in integer. It is not fractional.
No, it can be. That is not a. Even if capacity is integer, 500. Let's say it's 500. So that will not create problem, because it may not always. It's a continuous variable. Generator capacity, which is PG, it's a continuous variable. It may be between 0 to 500. It can take any value between 0 to 500. Yes, Suman, she has correctly answered. So we have to think something which can be either 1 or 2. Here PG can take any value. It need not be integer. It can take any value between 0 to 500, or let's say between 500 to between 50 to 500. Any value. It's a continuous variable. It's not a integer or a binary variable. There are some binary variables. So I want to know what are those binary variables. Can you recall some variables which are binary? Even associated with generator, there are some binary variables when we do unit commitment. But let's only consider the problem which we have seen in the lecture. Simple sizing and siting problem of energy storage. So in that, what is the binary variable or integer variable? Can you recall? So
Is it related to reactive power requirements?
Even reactive power is Q is also a continuous variable. It can take any value between two lower and upper limit. So one thing is the status, the charging and discharging status of battery. Either it is charging or discharging at a time. It cannot do simultaneously. There is one constraint that suppose, let's say C is that variable, D is variable. It should be less than 1. So C can be 0 or 1, D can be 0 or 1. If it is 0, then it will be 1. If it is 1, it has to be 0. Both cannot be 1 together. So this is a binary. These two are binary variables. Then one is, we have suppose 33 bus system and we have 33 buses. And we want to site energy storage. So we have 33 possible locations available with us. So at each location, energy storage can be present or not present. It can be cited or not cited. So that is a decision variable. That is a variable for me. Whether it is present or not on that bus. So it will be determined by the optimization problem. So that x value, that x variable, it will be 0 or 1. If it is in final solution, if it is there at bus, then it will be 1 at that bus. For other buses, it will be 0. So in that problem case study that was considered, there were at 4 buses the energy storage was cited. So at 4 buses that variable would take a value 1. At other buses it will be 0. So that's a integer variable or a binary, in this case a binary variable. Is it clear?
Yes.
So if we do network expansion planning also, then in network expansion planning we have an option whether we want to construct a line or not. So with each line we have one variable eta, which can be 0 or 1. If it is required to construct that line, it will be 1, otherwise it will be 0. So that will be decided by the optimization problem based upon the objective that we want to meet and the constraints that we have. Okay, so two more questions are there, but time is, I think, we have exceeded the time limit. So do you want to continue for 2 minutes or we should end?
This answer is B.
Okay, so this is done. State of charge is 80%, so depth of discharge is 1 minus 80%. And this is the last question. A 12 volt battery capacity is 500 ampere hour.
Answer is B.
Yes, so 80% SOC means 80% of 500, so it is 400. Correct. So today's, I think we have exceeded the time limit too much today. So
I have one doubt
Yes.
from the last assignment.
okay.
There was a last question which mentioned the power extracted in the wind energy system does not depend on which of these. And it was swept area, wind speed, pitch and turbine radius. And the correct answer was turbine radius. What I wanted to know is, isn't the turbine radius define swept area?
Yes, that is correct.
So actually the radius is also
See,
defining the output of the...
Madam, you are also right. It is given to me also. This question is wrong because area will cover both. So all get one mark in that question.
So that's why I did not select any of them, because I thought all of them are affecting the output.
But
it is the wrong answer.
But I have selected that. But mine is wrong. They said turbine radius, which is already covered in what you say in area. So
but that is how do you define? I mean, one can say instead of area can mention radius and still say this is correct.
That is why whosoever has attempted that question should be given marks. That is what I want to say.
So you can say options are not correct. They are ambiguous in this.
Yeah, and that's why, because all are right, so I did not answer it because everything was correct. So in that case, is it required that we, even though all of them are wrong, I mean, you can't pick one, you at least have to mark something? Is that so?
I don't know how they evaluate.
No, at least you convey this point to the instructor that that question is wrong, so they should give marks to all.
Yes. Okay, we'll do that. Yeah, one question is the SCADA measures magnitude and phase angle. Actually, SCADA, now VAMs we have these PMUs. PMUs, they measure these magnitude and phase angle for each phasor, voltage, current, phasor. But earlier we were measuring using SCADA only this power P and Q. So now with VAMs, next week we are going to discuss VAMs, PMUs. There we will see this. Now because of PMU, we have for each time instant these voltage and current phasors, their magnitude as well as angle. So we estimate phasors based upon the data that we get, because PMUs give us discrete data. We want to find out phasor from that, so we use DFT, discrete Fourier transform. So that we will see next week. So thank you all of you for joining today.